Now let's move on to a few equations which we need to learn for your syllabus. Okay. Now, as I have already told you that there is a transformer. Let us consider a transformer. Okay. This is the primary winding and this is the secondary winding. And let the number of turns here is represented by NP or N1 choices, yes. And the secondary side, it is N2 or it indicates NS. NS is secondary winding or N2. Okay. Now let us suppose the flux which is linking both the things is given by phi, and phi will be very generally sinusoidal in nature because, and one more thing which I forgot to say earlier, if a transformer is provided with DC, the flux will be constant. If the flux is constant, EMF is not induced because for EMF induction, okay, the formula is E is equal to d phi by dt. If the flux is not varying either with respect to space or with respect to time, EMF is not induced. See here there is no moving parts. So with respect to space nothing is moving. At least with respect to time there must be a movement of flux. And that is why your AC is coming into picture. That is why your transformers don't work in DC. In AC only they can work. Okay. So now E is equal to d phi by dt. Okay. Now your flux is sinusoidal in nature. This is how it varies. See, if let us suppose if this is your time periods, this is T, right? Your T is a time period, time taken for one complete cycle, which is normally given by 1 by F, right? See, what is the maximum change from 0 to phi m? 0 to phi. What is the change? See, d phi by dt. It is varying from phi m to 0 in a duration of t by 4. This is your EMF, if you carefully see. Okay, this is per turn. If there is only one turn, how much EMF is being varied? d phi by dt, right? d phi is phi m to 0 in a duration of t by 4. Right. So if you write it properly, you can get it as 4 pi m by t. And 1 by t is nothing but frequency. So its formula is 4f phi m. This is how it is being derived. See, average rate of change of flux is phi m by t by 4. So if I simplify it, I'll get 4f into phi m. This is for each turn. How many turns are there? On primary side there are N1, secondary side there are N2 turns. Right. So on primary side, EMF per turn is 4f phi m. On secondary side, also it remains the same. So when you multiply it with the number of turns, then you will get EMF which is induced. Okay. But this is still an average value itself. Okay. In order to get RMS value. Okay. What is form factor? Form factor is, what is form factor? RMS value by average. I want RMS value always, all the time. So what I should do? Average into form factor. What is the form factor of a sinusoidal wave? It is fixed, 1.11. So you multiply it, you will get RMS value. So here initially it was 4f phi m. If I multiply it 1.11, I will get RMS value of EMF per turn. 1.11 into 4 into f phi m. This is 4.44 into f into phi m. If you do have N1 turns, it becomes into N1. If you do have N2 turns, this is. So these are the EMFs which are induced in primary and secondary windings of the transformers. Try to remember the formula. E1 is equal to 4.44 f into phi m into n. This is frequency, this is maximum amount of flux, and this is number of turns. Okay. Now, both the windings have different number of turns, right? And you see what is E1 by E2 by E1? I'll show you. What is E2 by E1 in this case? Right, everything is cancelled. What you will get? N2 by N1. Very simple. N2 by N1. Which means, what does this indicate? What is E2 now? Very simple. N2 by N1 into E1. If you keep 100 here, if you are capable of primary 100 turns, 10,000 turns, you can get easily 10,000 voltage. This is how transformer works. It all depends upon number of turns, how much you are choosing. If you choose a large number of turns on the secondary, automatically what happens? Your secondary voltage is very high. Let us suppose if you choose less number of turns on the secondary, your secondary voltage is low when compared to the primary. This ratio N2 by N1 is called as transformation ratio. So voltage transformer ratio is given by ratio of secondary turns to primary turns. You call it as K, N2 by N1. It is equal to same E2 by E1. But it is inversely proportional to current I1 by I2. Try to remember this formula. As already said, if N2 is greater than N1, which means K is greater than 1, what you will get? E2 will be higher than E1, which means you are stepping up the voltage. That's why the transformer is called as step up transformer. If it is less than N1, then the voltage goes down. We will call it as step down transformer. Understand? Now, one more formula. Normally transformer has two losses. You see there are two important components, right? One is a core, the other one is a winding. Winding is made up of copper. So you will be having losses in copper winding and you will be having losses in core also. I won't go into detail in these things. So when you want to determine efficiency, output by output plus losses. How many losses are there? Core losses is there and copper losses are there. This is the way how you determine the efficiency. Right. Correct. So these three formulae, try to remember them. We'll solve problems on this one. And coming to applications of transformer, where it can be used. As already I said, there are two things. One is you can electrically transmit power. Electrically no connection, but you can transmit power. This is one advantage. Second thing is V and I levels can be varied. So where you can use these type of applications? Very simple. One is power transmission and power distribution. Electrical power is generated somewhere. It is stepped up to some high values and then transmitted. Again, it is stepped down based upon our requirements. Okay, so for transmission and also for distribution, we will be using. For power transmission, we will be using step-up transformers. And at distribution side, what we will use? We will use step-down transformers. Right. And also in electronics. See, in electronics, we do use so many type of amplifiers, audio amplifiers, power supplies, electronic ballasts. All they do require different amount of voltage. So how to adjust the voltage? Simplest way is nothing but use a transformer in AC circuits. Okay, and also in railways. Even railways also they use, there are high voltage lines, right? If you see the tracks, they use high voltage lines. They will step down that voltage when it comes back to the train. They will adjust the voltage. They will use transformers only. Okay, so like this, even in your mobiles also, if you carefully see, your supply is 230 volts. Your residential supply is 230. Right, but your mobile charger requires only 5 volts. What you will do? You will use a transformer, reduce your 230 volts to some 9 or 10 volts, and then you convert it into DC and give it to your mobile or laptop or something else. So transformer is a part in your daily life. Okay, it just reduces the voltage level or increases the voltage level based upon your requirements. Okay, got it? So I will close this with small numerical problems now. See, this is one numerical problem. If you carefully see, yeah. See what has been given. The number of turns on the primary side and the secondary side are 25 and 250 respectively. So what they are giving us, that N1 is equal to 25, N2 is equal to 250. And they are saying that voltage on the primary side is 125. I will take E1, neglecting losses, I will take E1 is equal to 125. Voltage on secondary side of transformer. E2 is equal to how much? Okay. Now, determine current on the secondary side. If the current on, they are also giving I1. It is 20 amperes. They are asking us I2 also. So this is here data which has been given for us. We know one thing. We have already seen transformation ratio. K is equal to N2 by N1. This is equal to E2 by E1. I1 by I2. So N2 is given for us 250, N1 is given for us 25, E2 is not given, E1 is 125, I1 is given as 20, I2 is equal to. Now I'll take these two. What is this one? E2 is equal to 250 into 125 by 25. 25 ones, 25 tens, I'll get 1250 volts. Or otherwise I'll take this one and this one. This is 250 by 25 is equal to 20 by I2. What is I2? 25 into 20 by 250. 25 ones, 25 tens, what I'll get? 2 amperes. So I2 is equal to 2 amperes. And E2 is 1250. This is how we solve the problems. Okay. Now the next one, see here. A single phase transformer has 500 turns on the primary and 100 turns on the secondary, which means N1 is 500, N2 is equal to 100. The maximum flux linking both